next concept is regression. Now, in general, we have an equation expressed as y as a function of x, where we say y is the dependent variable and we have the x as the independent variable. So, the value of y is actually dependent on the value of x, right? So therefore, if we are changing x, definitely we can change y. So this is the general format of a equation y is a function of x. Now, if we have this equation given, if we know the value of x, we can definitely predict what will be the value of y. Or if else we have the equation of x given, right? Equation of y is equal to x given. If we know the value of y, we can definitely find out what will be the value of x. So in either way round, definitely if we know the relationship between y and x, if we know one, we can definitely find out the other. Now this is the basic concept from which the regression is used. Now when we have a situation of this sort, that y is actually having a format of a plus b into x, right? A plus b into x. So we have the power of x as equal to 1. So this is the most primitive form of equation which we say, and it's actually the equation of a straight line. So this is said to have a linear regression, right? That means if x is changing by 1 unit, even y will change by a specific unit, right? So there is a specific correlation between x and y, and they actually vary linearly with each other. They vary linearly with each other. So that's the concept of linear regression. That is the concept of linear regression, right? So this is what we say is a linear regression. Now, a situation, or what we say, it is the most simple form of regression or linear regression. A situation where may definitely come where we talk about, say, multiple regression, where y is not only dependent on x, could be some other variables. Now, if I talk about y being the sales, right, and we have x as, say, the promotional expenditure, right? Promotional expenditure, y is the sales and x being the promotional expenditure. Definitely we have to have an understanding that if we know the value of x, we can predict the value of y, and if we have the value of y, we can definitely find out what will be the value of x, right? If y is equal to the sales, and so this is how here they are linearly varying with each other, right? So it's what we say is a simple linear regression. Now, most of the time in practical life situation, it's not that only that sales depends only on promotional expenditure. It could be even other things like the distribution efforts. So y could be definitely depending on another variable, that is the number of outlets that are there, or the number of salesperson that have been employed in the process. So it could be a plus bx1 as one of the variables plus cx2, where we are having x1 and x2 as two different variables affecting y, right? Having affecting y, or it could be another one as dx3, right? So here definitely we have the function as y is a function of x1, x2 and x3. So this is a case which we say is a multiple regression, right? Multiple regression, once again, which we say if it is having the power of 1, they are said to have a linear regression. So this is a multiple regression. And this is what we say is a simple linear regression. This is said to be a simple linear regression. And this is could be even multiple regression. Multiple regression could be linear, or it could be definitely be parabolic, or can be even having a quadruple. It actually depends on this what we say the power of the independent variables, right? That will determine the character of how y is changing with the values of x's. So that's what is the concept of multiple regression. Now, with this as concept, let's start off, right? We introduce the concept of regression equations. Now, what are regression equations? Now, regression equations, we will talk about two different types of regressions which are commonly used. One is the regression equation of x on y, and the other as the regression equation of y on x. Now, when we have the situation as the value of x is given, right? The value of x is given, find y. Please remember, whatever we have to find will come on your left hand side. So it will be given by the formula y minus y bar. Bar actually is the mean of y, is equal to b xy So it's a situation which we say x is given, we have to find out y. So in that case, the type of regression equation is, we have to find y. So it is y on x. We have to find out y on x. So the type of regression equation is y on x. So it is whatever you have to find will be on your left hand side, and it is y minus y bar is equal to byx into x minus x bar. X minus x bar, where y bar and x bar are the means of the variables x and y, where x bar and y bar are the means of the variables x and y. What is byx? Byx is said to be the regression coefficient of y on x. It is the regression coefficient of y on x. Number two, it is said to be the regression coefficient of y on x, and byx is given by the formula covariance of xy by sigma x's squared. It is given by covariance of xy by sigma x's squared, right? And then we talk about a situation where we have it as we have y is given and you have to find x. Y is given and you have to find x. So whatever you have to find, right, it will come on the left hand side. So here the regression equation type which we have is x on y. It is the regression equation of x on y. So the formula now becomes x minus x bar is equal to bxy into y minus y bar, where x bar and y bar are the means of the variables x and y. And what is the value of bxy? Bxy is given by the equation covariance of xy by sigma y square. It is given by sigma y square, that is equal to variance of y, right? That is given by variance of y. Okay. Now, what is covariance of xy? How do we write the value of covariance of xy? Covariance of xy once again is given by the formula 1 by n summation of x minus x bar into y minus y bar. What is variance of x, right? Variance of x, it is 1 minus n summation of x minus x bar the whole square. What is variance of y? Variance of y is given by 1 by n summation of y minus y bar square, right? So therefore, we can definitely find out by using these formulae the value of bxy and byx, and therefore we can definitely compute the regression equation of x on y and y on x. So let's have a problem. Let's take a problem and let's try to find out how the regression equations can be computed. So here the problem says that the advertisement expenditures given in lakhs are given, and the corresponding sales for 7 different years are collated, and the sales are given in thousands of units. And it's given. So you are asked to find out the regression equation of x on y and the regression equation of y on x. And you are also asked to find out in the problem, find the advertisement expenditure required, right, to attain a sales of 20,000 units, and what will be the sales amount if the advertisement expenditure is 15 lakhs, right? So first we have to find out, the first part says that find sales, that's y, when x is given, right? This is a specific case which we find. You have to find y when x is given. So definitely the regression equation that you need is y on x. And you have to find x when y is given. So this is the case where you require the regression equation of x on y. So we have to find out both the regression equations. So let's find out, and for that we need to find out covariance xy. We have to find out x bar, we have to find out y bar, and we have to find out the variances of x and y. So let's start off. So here we have the summation of advertisement expenditures as 49. So from here definitely we have 7 observations. So we have the x bar value as equal to summation of x divided by the total number of observations. So that's equal to 49 by 7, coming to be 7, right? And similarly, we can find out the value of y bar, that's equal to summation of y by n. Summation y, we get the value to be equal to 70. So here we'll be all getting the sums here. So summation y, we get it as 70. 70 by 7, the value will be 10. So let's find out what will be x minus x bar. X minus x bar, the first one will be 0. Then we have 10 minus 7, that's equal to 3. 9 minus 7, that will be equal to 2. 4 minus 7 will be equal to minus 3. 11 minus 7 will be equal to 4. 5 minus 7 equal to minus 2. And 3 minus 7 will be equal to minus 4. Right? Correspondingly, we have to find out y minus y bar. Right? We got y bar as equal to 10. So it's 12 minus 10 coming to be 2. 2, 14 minus 10 coming to be 4, 13 minus 10 coming to be 3, 5 minus 10 coming to be minus 5, 15 minus 10 coming to be plus 5, right? We have 7 minus 10 coming to be minus 3 and 4 minus 10 coming to be minus 6. So what will be x minus x bar into y minus y bar? We have to just multiply the two. So it is equal to 0. 3 fours are 12. It is 2 threes are 6. This comes as plus 15. Both are negative. 4 fives are 20. We have 2 threes are plus 6 and 6 fours are 24. If we are adding this up, we get 24 plus 6 is 30, 30, 50, 50 plus 15 comes to be 65, 65 plus 6 is equal to 71 and 71 plus 12 we get it as 83. So the summation value which we have got for x minus x bar is equal to 83. So we can definitely substitute this value and we can find out the value of covariance xy in this case. So this is which we have got. N is the number of observations that we have got is equal to 7. So it is 83 by 7 which we find as the value of covariance of xy. Now we have to find out x minus x bar the whole square. So the value is 0 here. And we have 3 square is 9, 2 square is 4. This minus 3 square once again will be 9. This will be 16. This will be 4. And this once again will be 16. And if we go in to find out the summation value for x minus x bar the whole square will be equal to 58. So if you have to find out the variance of x, it is simply putting here the value of summation x minus x bar the whole square. That's 58 by the number of observations. So that's equal to 58 by 7. Right. Now we have to find out the value of y minus y bar the whole square. So that's equal to 2 square, that's equal to 4. This is 4 square coming to be 16. This is 3 square coming to be 9. This will be 25. This once again will be 25. This will come to be 9 and this will come to be 36, right? So if we have to sum it up, we find the value to be 124. So the summation value will come to be 124. So here we have the variance of y as equal to 124 by 7, right? We get the value as 124 by 7. So we have found out made the basic calculations. Now we have to find out the different values, or we have to find out the different regression equations firstly, right? So the first question says, find out the value of the sales when the ad expenditure is given to be 15 lakhs. So first let's find out the regression equation of y on x. So let's find out the regression equation of y on x. So y on x is a situation when we have, right, find y, x is given. And I said whatever you need to find will come to your left hand side. It is y minus y bar is equal to byx into x minus x bar. Okay, it is y minus y bar is equal to byx into x minus x bar. So let's find out what is this byx. Right, y minus y bar, so it is equal to, so we have the equation as y minus y bar, we have already got it to be 10, is equal to byx, and that's equal to nothing but covariance of xy by which we have the summation sigma x squared, which we have got as sigma x squared. So that's the value that we have. So sigma x squared into x minus x bar, so we got it as x minus 7. That's how we actually find it out. So the equation says y minus 10 is equal to covariance xy. We got the value to be 83/7 divided by sigma x square, that's the variance of x, and that which we have got is equal to 58/7, right? So this by 7 definitely gets cancelled out and we get the final result, and we solve it and we get the final result. It's y minus 10 into this. So solving for x, we definitely find out, we find out the value as y is equal to minus 0.017 plus 1.3 into x. Now, the problem says that find out what will be the sales when you have the promotional expenditure to be equal to 15 lakhs. So we have given the x is equal to 15 lakhs, and since we have got all the x values in lakhs, so we have to just substitute the value of x to be 15. So it will be y is equal to minus 0.017 plus 1.43 into 15, right? So we find out what will be the corresponding value of y. So we get it as minus 0.017 plus this will come to be 21.45. So if we solve it for the value of y, the value of y comes to be 21.433. Remember that it is given in thousands of units, so we have to express it in thousands of units. So y is equal to 21.433 into 10 to the power 3 units, right? So it is 21,433 units, right? So that's y on x, right? From the value given of x, right, we have the value, we found out what will be the value of y. The value of x was given to be 15 lakhs. X is equal to 15 lakhs. Now we come to the next situation. Next situation we have found the next part says that the value of y is given, right? The value of y is given. You have to find out the value of x. Now in this case the sales is given. So for a sales value of 20 lakhs, what should be the advertisement expenditure? So here it is find x when y is given, right? So here y is given to be 20 lakhs. So here in this case it is x on y. It is the equation of regression equation of x on y. So we get it as x minus x bar is equal to bxy into y minus y bar. Okay, so we have the value as x minus 7 is equal to bxy, that's equal to covariance of xy by sigma y square, that's variance of y, into y minus 10. So we'll just substitute the values of covariance xy and the variance of y square. So that's the value we get it as x minus 7 is equal to 83/7 by 124/7 into y minus 10. So we get it as x minus 7, or in fact x minus 7 is equal to 0.67 into y minus 10. Now given here y is equal to 20 lakhs, right? Given y is equal to 20 lakhs, right? So y is equal to 20, we are going to just substitute the value. So we get x is equal to, or x minus 7 is equal to 0.67 into 20 minus 10, that's equal to 10, so it's 6.7, right? 6.7. So x is equal to 7 plus 6.7, and that's equal to 13.7 lakhs. So we want the y as 20,000 units. It was not lakhs, rather it was 20,000 units. 20,000 units. It was 20,000 units. So for getting a sales of 20,000 units, what should be the advertisement expenditure? So it comes clearly as 13.7 lakhs, right? For 20,000 units, we get the ad expenditure that needs to be made by the company as 13.7 lakhs. So that's how we calculate the correlation from the covariance factors, covariance and the variances. We find out the bxy and the byx, and that's how we get the regression equations, right? And how using the regressions equations we can predict